going to discuss the binary tree traversal. That is the traversal of the binary tree, and in this case binary tree is not sorted form of the nodes. So that is the, in case of search tree, binary search tree, in the node structure is sorted. So we can say that the left node is the less than the root node and right node is the greater than the root node. But in case of binary tree, it is not that form. That is, the root is appointed, root is posted at various point, and it is not a sorted form. So when we are going to define the node of the node traversal, binary traversal, then first we have to define the node. That is the definition of the node by class. That is, I here define a node, class node, and this is the first stanza, first starting of the definition of the node and starting to traverse the binary tree. So node, here the two types of two argument is there, self and key. Self, that is data accessing data, and value is taper data, and another key is initialized by none. And at second point, that the another method is defined. This method print in order node. Node here is the argument, and by this method we want to point out a definition of the node, and if any value is not there, the node carry no value, then it is returning null. In case of the binary search tree, in case of binary tree, the searching p-order search, this is a p-order search, then first we have to take the left node, then center node, that is root node, and then right node. So in this case A, B, C is the combination. So first we have to take left node, then the center node, and then the right node of the binary tree. Now we have to define, we have to print out the details of the traversal. So one by one we have to travel, that is the from left node, and then we have to print the left node. From root node we have to pin the root node, and again we have to take the right node, and you have to pin the right node. So each and every steps we have to take the details of the node and to print each node one by one. And this print out is not in the line by line, but is the one line. So here end equal to this format is also utilized, because in this format we'll delete the one by one line printing. It will print one line in one line. So end equal to the colon, semicolon, that is used for the printing of the one line printing. Now this is the one line printing, and now I am coming in the right. So first I started the left node, second I am already utilized the center node, that is the root node printing, and then next I am printing the right node. So left node, root node, and the right node. One by one we have to take the node, and we have to print the node one by one by this function. And here we have utilized one function that is called a diver, and this function why we are using if underscore main equal to underscore, if underscore name equal to underscore main. This function, when we are using the skip directly in the function, directly in the skip, directly in the program, then this function will be utilized in the Python. And after the last point, we have to define the node. Already the function is defined. One by one take the value and we'll pin the value, but at last I am defining the node value, that is root dot left equal to node 2, root dot left equal to net 4, and in this case each node contains two value, one is left value node and is right value node. So each node we have to define the two types of node, the child node, that is child left child, also for the right child. So root dot left equal to means that the left parts, left side node of the root node, and root dot right equal to value of the right node of the root node. In this way, root dot left equal to value is the left of the root, and right of the root. Similarly, this is why we have to define the total node value of the function. And last we have to call the root, that is a print in order function for total display of the traversal report. And this way the traversal of the binary tree, not binary search tree, we have to find out we can display the total value of the binary tree at a one by one steps. Now I am utilizing the Python for one by one steps and taking steps. Please see the total programming, and this programming will help you how the binary binary tree is utilized, or we can take the details of result of the traversal of the binary tree. First we have to define, I have already said, the class node. That is the class node is our first criteria, first step. Class node. Under class node, we have to define a method or function. Method or function, it may be, we can say function or method INIT. INIT self, and here I have defined not data but V. Why V? For some logic, that is V. Okay. And okay. Self V. Now, second stanza, we are taking the data, that is the self dot data equal to V. V is here defined dot V value from self by data. Again, self dot left equal to none. The left value is initialized by none. Again, self dot right, that is the right value of the root, is initialized by none. It is the end of this method. That is method name is INIT method. Now again I am coming the another function, another print order to print, or another method, that is the def. Method name, I have already defined the method name, print in order method, and print in order, and the method is print in order. Your argument is note. Already note is defined as before, that is class note. And here one condition, that is the if node is none. If node, here if node is none, I want to define that if node is none, then the return value, then it will return nothing. Return to the function. Okay. So if node is none, then return value is coming. Return, that is the return is none. Again, I am coming the next stanza, that is the print. That's this print function, print in order. Here print in order, why root dot right, root dot left, and node dot right. Left, root dot left and root node dot right. Two types of function, one function but two argument is there. Print in order function and root dot left. Sorry. Print in order, root dot left function. And again, we have to print the value and print in order. Value means print in order function, value of the print in order. That is print note dot data and end, and that is the print, and only printing the value. Okay, now again the coming the next function, that is note comma right. node dot left, node dot right. Two types of node. One right node of the node, right node or left node of the node. Pinned in order right. Okay. Deletion already found, so to define here as the dot right. Okay, and next pinned in order dot node dot right, right last name, and then another function that is if name dot main equal to main function, and again after it root function root dot left, two root dot right, two root dot left 4, 5, root dot right left 6, root dot right left 7, and again pinned the root. Now okay, okay, already program is complete, and now I have to run this program, and 0, no error is there, and the result will come like this way. So 1, 4 to 6, that is 4 to 5, 1, 6, 6. This is the result of this coding. So each and every process, if we follow the process, then we have to define, we have to show the pre-order traversal. In-order traversal. It is in-order traversal of the node of this node. This in-order traversal of the binary tree. So this is the end of the video. Thank you everybody for this subscription. Please subscribe the channel for the next video. Thank you.